Does anyone recall hearing the phrase significant digits or significant figures in a different science class? Some of you have, okay? You were probably introduced to the concept, maybe did a little bit with it. Whether you remember any of that, who knows? Okay, it doesn't matter because we're going to go through it all anyway. Okay, anyway, let's start there. Depending on how old your teacher was, they either use the word significant digits, or if they were like me, significant figures. And knowing that you guys are all relatively new and young, I don't think there's anybody old enough that used significant figures. You may want to know what the word significant digits refers to. I will say this, the word significant is not the way you use it in your English class. Okay? It only refers to Stop.
Do you want to erase this off?
Yes.
Actually, yes, I think you might.
Yes. Just out of curiosity, has anyone ever been asked to write a bunch of stuff on a board before?
Not a bunch of stuff.
Do you ever kind of get lost sometimes?
Yeah.
I mean, because, you know, when you're on a bigger scale like that, my brain works way faster than my hand
Right.
does, so now I'm like 3 words ahead, and I start like, doing weird things.
Skipping words.
Skipping words.
Putting words twice.
Or
I start writing really quick.
adding or making 3 words into one
Yeah.
kind of thing.
And then you forget what you're gonna write after.
Yeah. When you stop.
So yes, you have
pause.
spent some time doing it.
Yes.
All right, moving on. So any value that was capable of being measured with an instrument is said to be a significant digit. So all those values that we wrote down on our little practice that we were doing, I guess it was mostly Monday, if I remember correctly, are said to be significant. So if we look back, some of you are still on that same page. What was the measurement we came up with for the ruler? They want to have that nearby? 11.32, okay? Well, all of those values obviously were capable of being measured on that instrument, so there are 4 significant digits. Pretty darn easy, right? On the graduated cylinder, what did we come up with?
18.8 or 18.7.
Okay, I wanted to work a 0 in there. But anyway, 18.8 or 18.7, right? All those capable of being measured, so 3 significant digits. What about the balance? I know we did like 3 or 4 of them.
2.63.
One of them was like 7.
No, it wasn't.
Yeah,
Seven.
107.7.
There we go, 107.730. And we wrote all those down, right?
Yeah.
Because somehow or other we were able to account for them on that that scale, that balance. 6 significant figures, right? Okay, that's a good one to refer back to. We'll come up with that a little bit later. What I want to do is go through some examples into how to determine how many significant digits are in a measurement. Here's the overview of what's going to happen. And again, I keep referring to measurement, okay? Significant digits only apply to measurements and calculations with measurements. You guys are sitting in your fancy math classes, they're telling you things like fractions and stuff in your answers, right? Why is that?
good
they told me.
question.
It's a darn good
Yeah.
question.
So the answer can be accurate.
We're gonna have accurate answers also, without using fractions. Fred, you up?
So you have to write this into decimal places.
No, that's not why. Okay, let me put it this way. When you guys are taking your fancy math classes, you're learning skills. Believe it or not, okay? You're learning skills, okay? Most of those things that you're working with aren't measurements. You're learning the language of numbers, basically. How to do things with numbers. Now those skills hopefully get applied in other things down the line, for example, chemistry or physics or something like that, okay? But you're learning skills. A lot of times, you will have heard this phrase, because the fraction piece represents an exact number. You guys heard that piece before? So they might tell you to put it in like 7/8 without reducing it, or they might say put it as 17/5 and keep it that way,
Yeah.
right?
Yeah.
Because that represents the exact number. There's no rounding involved. And that goes back, who talked about the decimal points? Somebody back there did. Okay, yeah, somebody did. Okay, so yeah, but not because, so you don't have to write them, it's just because it represents an exact answer, okay? When you start writing and rounding, now you no longer have an exact answer. But most of the stuff you guys do in your math classes aren't with measurements. You're just dealing with numbers and learning how to manipulate the numbers. For example, you guys have these billion-dollar calculators. I've seen them all over the place. You guys do a bunch of calculations on those billion-dollar calculators. You get 52 numbers in your answer. Okay, maybe not 52, but you get a bunch of numbers in your answer, right? Here's my question to you. What goes through your brain in deciding when do I stop writing down numbers? How many of you write down all of the numbers that show up on the calculator? Good, because that would be dumb, okay? That would waste a lot of time. So what method do you use? When do you stop writing down numbers?
I usually stop after, like, if there's a 1 or a 2, something that can't be rounded up to the next digit.
Okay.
Thousands place.
Thousands place. Okay. What if this showed up on your calculator? Here's your answer. Right? So what would you do then?
I need to write it out.
You would write out the whole thing? Okay.
Well, typically the directions say round to this.
Then there's that. The teacher flat out says, round to this. Okay, there's that piece. So they've already done the work for you.
Pretty much,
You can do the thing where it's like 10 carve this.
Yeah, it's called scientific notation. You can. Okay, so write this in scientific notation. Again, you're going to have to make a decision as to when am I going to stop writing down numbers. When are you going to stop writing down? Are you going to write down all of those? Would you?
Yeah, you have to do scientific
We'll learn differently in a little bit. So you would write all those down? I'm just asking. You're not fired.
Actually, no, for that one, I would put like maybe the 4 and the 6 and the 8.
Okay, and then stop after that.
Yeah.
Right. So again, you made a decision to stop writing down numbers for some reason. Who knows what method you used to come up with that, but you made a decision, right? Are we noticing I've talked to like 4 or 5 different people, and we've got 4 or 5 different decisions that were being made, right? Okay, well, I'm going to take the pressure off you guys and actually show you with measurements, there is a system that we can use to help that decision be made. Okay, anyway, moving on. We'll get back to that scientific notation bit here in a little bit. Okay, that was a good example of the thousands place. I was waiting for that one. Where's my notes that I just made up 25 years ago? I'm going to write down 6 measurements. I would suggest going 2 columns, just like I'm going to do, and leave 2 or 3 lines between each one, because most of the measurements, we're going to take that one and then do things off of that. So here's the first one.
Are you gonna always want a zero before the
Well, we'll talk about that too. Who asked that question? Okay. To distinguish you from the Emily Brown? Emily's fine. All right. Emily, I'm going to have you answer that question for yourself. No, I'm just. No, I haven't done the exam. You're going to get you're going to get your own special running plan and your own special question here.
Sounds good.
You ready? Okay. Now I've got to ask you 2 questions. How many significant digits? Good answer. What's that number?
784,000.
I'm just asking you, what is this number?
Oh, 0.78.
Say this again.
0.784.
Lucas, what's wrong with that answer?
I can't tell. Put it in that spot because there's a little mark there.
There's no mark there. Didn't we cover that in this class?
No.
Oh, that's why you need a zero.
Thank you.
Okay.
Emily, how old are you?
15.
Right? You're 15.
Yeah.
Do you ever write your age that way?
No.
Why not?
Because that's not how we do it anymore.
Okay. Yes, fair enough.
Where'd you get it?
What's that number?
0.784.
0.784, right?
Yeah.
How did we know it was 0.784 rather than just 784?
Zero.
Because there's a 0 in front of it. See where I'm going with that? Get in the habit of doing it. How many of you do that anyway?
Oh, it's not.
Just a handful of you, okay? Start getting in the habit, because I'm sure you guys have all had this scenario, just like I did. I mean, thank you for playing. You did exactly what you were supposed to do. You weren't sure, because you weren't sure whether that was a decimal point or whether that was just a stray mark. And I know all of you have run into that in papers before, like your math classes or something. You'd even ask your teacher, is that a decimal or a comma or some sort, or is that just a stray mark? Has that ever come up before in your classes? That way, there's no ambiguity as to whether there's a decimal there or not. No 0, no decimal. If there's a 0 in front of it, we don't write things like that way in America. So, there must be a decimal after that. Does that make any sense? All right. That just makes it more clear. Okay, moving on. Next, we determined, and Emily answered this correctly, would you guys all agree, 3 significant figures?
Yes.
Excellent. Can't go wrong with that. As it turns out, there's only one number that ever causes any problems when you're figuring this out. Does anyone want to take a stab as to what that number is?
Zero.
Zero screw things up. Okay? In fact, there is a whole list of rules to follow when you're trying to figure out how many significant digits are in the answer. This particular version has 6 rules. Let me read 1 or 2 for you. This is really clear, very clear and understanding. Here we go. In numbers less than 1 and greater than -1, zeros to the right of a decimal point that are to the left of the first non-zero digit are never significant. You should see the look on Megan's face. Did that sound like this? Okay? I don't even know what that means. And I'm really good at this. Okay? Here's another one. Zeros to the right of a non-zero digit, but to the left of an understood decimal point are not significant. If such zeros are known to have been measured, however, they are significant and should be specified as such by inserting a decimal point to the right of the zero. What? Okay, so what I'm going to do is summarize this list of 6 unintelligible rules into 1 1/2. Okay, I gotta throw the half in there. We'll talk about that in a second. We've already actually addressed it. Here's the rule that you need to know as far as zeros are concerned. Now, we're all clear that if it's not a zero, it's significant.
Yeah.
This is the zero rule. If a zero is only serving as a placeholder. Found out in my other classes today that we need to find out what placeholders are. But anyway, if a zero is only serving as a placeholder, it is not significant.
What is it? The zero.
And then there's that.
Yeah.
Yes.
Does the placeholder be the zero before the decimal?
Sometimes. I know. Sometimes. So here we go again. If a zero, I'm just restating it last time. Zeros serving only as placeholders are never significant. All other zeros are. That's the first rule. Now we need the half. That zero that we just talked about, because we don't write numbers like that in America,
Yeah.
that one is also never significant. That's just there to show us that there's a decimal point.
Yeah.
Okay. So now, let's go ahead and start applying the rule. But Adrian has a question that 7 other people also want to know. What's a placeholder? Anyone want to throw something out on that? Go ahead, Amy. It's hard to describe, so do the best you can.
It's something that's there that represents something else.
It's not representing something else, because we're talking about zeros here. It's representing 0. Gavin?
It's only there to make the other numbers in the correct location.
I don't know if that's what you had in your head and it didn't come out that way. That could be, we all have been through that before. Okay? Gavin's got it. It's a 0 that's in a place to make sure that other numbers end up in their proper decimal place. So far, so good. You guys knew this since like 5th grade. You just forgot. Okay? So for example, and this is going to be fun. We got 6 examples to go through here today. Actually more, because I'm going to add some more. I'm going to ask you all when we get to each one of them, how many significant figures that value has. I'm going to say ready, set, go. And I want you all to say what you think it is. At first, we're going to have like 3 or 4 different answers for each one of them, because you guys don't know what you're doing yet. But as we go through, hopefully, by the time we get down over to here, everybody's saying exactly the same thing. So here we go. This measurement, how many significant digits?
4.
There we go. We got 3 different answers. 2, 3, and 4. Now we're going to apply the rule that I just gave you and figure this out. Are there any zeros in this measurement that are only serving as placeholders? Once again, what's a placeholder, Gavin?
There to make the other numbers in the right place.
Okay, a 0 that is inserted to make sure that the rest of the numbers are in the correct place. Megan, do you have something to offer here?
So then when is it not?
Well, we're going to get to that.
What?
Right now I'm asking, are there any placeholders here? Here's a good way to find out. What's this number?
6,070.
What's that number?
607.
Why is that 0 there? To make the 6 in the thousands place, this 0 in the hundreds place, and this 7 in the tens place. If that 0 were not there, then these would no longer be in their proper places. Would you guys agree?
Correct.
Is that 0 a placeholder?
Amazing.
Great. Yes. Is it significant? No. Everything else is. So how many significant digits? 3. Now listen, I know there's about 5 of you that go, oh, I get it. There's about 8 of you that are like, I think I got it. And there's like another 5 or 6 that are like, I have no idea what's going on. However, you will by the time we get over here. There are currently 3 significant figures. Emily Gray.
Alright, but like, so are significant, are the zeros that are usually the placeholders like at the end?
We're going to get there. Trust me. Have faith. Have faith. I got you covered. Have faith. Adriana.
So how's the 0 in between the 6 and 6?
Okay, excellent question. Alright. What's that measurement?
6,070
Okay, go ahead.
6,070 decameters.
Deci.
Okay, decimeters.
6,070. Is it at least 6,000?
Yeah.
Is it 6,100? No, it's somewhere in between there. You estimated that to be right around 70. Okay? Was the 6,000 piece measured? We know it's at least 6,000. Was the hundreds place measured? Do we know that it is or is not at least 100?
Yes.
You see where I'm going with that? We definitely know that it's not 100. But so we're accounting for it, are we not? And then obviously the 70 we estimated. That's why that 0 is significant. Okay? 3 significant figures, right? Now, here's the net. I'm going to extend this one a little bit. And again, I go back to, we only worry about significant figures when we're talking about measurements. We're doing a lot of measurements in class. We're using a lot of problems and exercises that have a lot of measurements in there. We're going to do a lot of calculations with these measurements. There's a set of rules, very similar to the example I gave you earlier, like when do you guys stop writing numbers down? You're going to do all these calculations. You're going to have 52 numbers across your calculator. You've got to make a decision as to how many of those actually are valid numbers to write down, how many are significant. There's a set of rules that are going to guide that we're going to start talking about next week, okay? Anyway, so now you've got this number on your calculator. So let's say you have 6070 on your calculator. But because of all the rules that you're going to learn next week, you have to write your answer to 4 significant figures. So somehow or other, I have to write 6070 on your calculator says 6070 to 4 significant figures. That currently has 3. How can I make that number have 4 significant figures? Your first answer is wrong. Go ahead and say it anyway.
You round it up to 1.
Round what up to 1?
The last 0.
What would cause me to round that up to 1? Now, I could give you an argument for rounding this one up to 1, but that only makes us 2 significant figures. I think you get that argument too.
Yeah.
I don't see anything that's causing me to round that up to 1. Not Paul.
Nope, still not Paul.
I have no idea. Brandon.
Nope.
Start with a B.
Close enough.
That was
Yeah,
really
it's
close.
right.
Oh,
Close enough.
Brennan.
Yes.
There we go.
Alright, so you add like 0.0, so then it holds.
And like I was saying, not only was the first answer wrong, so was the second answer. You were half right.
It was
Megan.
6,069.
No, because then we lost stuff.
How's that?
Gavin.
I was gonna say point and something that's not 0, like 1.
Well,
Yeah, like 1.
here's what you do.
No, it's 0.
That's it.
That's it.
That's it.
There's
That's it.
Because it means there's something after.
Wait.
No, it doesn't mean there's anything after, but that means, all that does is says that 0 is significant. That's all it says. Now, going back to what Brennan had said. Now remember the rule for zeros. If it's serving only as a placeholder, it's not significant, all their zeros are. If I put a 0, is that 0 a placeholder? No. What's it holding the place for? Nothing. Then therefore, it's significant. So this actually has 5. Okay? So we stop there. Now we run into the Emily problem, though. Which will forever be known as the Emily problem. Okay? Could it be possible that this is misconstrued as a decimal point? Or sorry, as a stray mark? It's possible. So this is an okay way, and I'm fine with this. But actually the best way is only writing your numbers in scientific notation. Why is that? What is the purpose of scientific notation? And it's not what you thought it was. You thought it was to make it easier to write numbers. Big ones and big numbers, small numbers, right? Because what aren't you writing? Zeros. Those zeros are not significant. So when true, the whole purpose of scientific notation is to only show significant digits. So if all 4 of these are significant, I would write 6.070 times 10 to the 3rd. That way there's no doubt that that's significant. Anyway, I'm just saying. Either one of these would have been acceptable. I would perfectly be happy with either one. Somebody had a hand up that I caused you to put it down. Okay, next. We're down through 2 examples already. Let's see if we've gotten any better. How many significant digits are in this measurement? Go.
4.
I heard a bunch of 3s. I heard 1 4. Were there any other 4s? I heard 2 4s. Well, let's go through it. Is this significant? For the reasons we've already talked about. Is this significant?
No.
I'm just asking.
No.
Why not?
It's a placeholder.
Yeah, yes. It's a placeholder. Is this one significant?
Maybe.
No.
If I get rid of the 0, does it change the value?
No.
Then why did I write the 0?
I don't know.
Because it was capable of being measured on the instrument. It's just that it ended up being exactly on the line.
So this
So
one
it's-
is basically flipped.
She's got it.
Okay.
Listen, I understood what you're saying. Nobody else did. That's weird. But anyway, there's 3 significant figures here. We're getting a little better. Yes, Freddie?
If adding a 0.0 on the end adds an extra significant figure, but adding a 0.0 in the beginning doesn't?
No, because remember we talked about why that's there, to show that there's a decimal point.
That's where you said that.
I know. All right, moving on. Yes.
So the 0 after the decimal, why isn't it significant?
Because it's a placeholder. Okay, because if I got rid of that 0, does that change the value? Is that a different number? Then that's because this is a placeholder. I need to make sure the 5 is in the hundredths place and the 4 is in the thousandths place. Okay. Ready, set, go.
2, 3.
Look at you. You're going to be that person, aren't you? You're going to be that
That's
person.
always that person.
Okay, time out. What if I wanted, that's the answer I got on my calculator, doing all my fancy little number pushing, and that's why I got my calculator, but for reasons that you haven't been taught yet, I would have to state that result to 5 significant figures.
0.
No.
To 5?
0, 4.
Oh, 0.00.
There you go, 0.00.
Why?
Because he wants to.
No, because of this. Because of this. Give me a second, I gotta think this one through. Oh gosh, this is gonna be hard. This would be like a balance. This is gonna be really hard. so this would be, oh, yeah, this is not that hard. Yeah, 5, 6. And let's say there's other information up here that has the 400 and the, okay, boom. Now I'm trying to think. No, I'm trying to think what I want to do here. I don't think I can make that instrument to go out to 5 in a relatively fast way, so I won't do that. But where I'm going with this is, if this needed to be to 5 significant figures, we need 2 more digits. All right, moving on. Everyone together, stay out of it. Go.
3.
See, this was easy. 3. How about that? Yes, Paul. 2. But then I had asked, what if I wanted to write it as 5? And we had to put 0.00. Okay, this has 3. What if I wanted to state, now I'll just ask, what if I wanted that to be stated to 4 significant figures? Put a 0 after the 3. And what if I wanted to write that value in scientific notation? I know you guys should know how to do this, I'm just checking. Go ahead, Angel. Negative third. 10 to the 9.03 times 10 to the negative third. Because it's less than 1. Because it's less, you know that. And everyone together now.
3.
I heard a 4. Who was it? All right. It is 3. Currently, as it's written. Here comes a fun piece. How would, again, this showed up on your calculator, 96,800, but for rules that you don't know yet, you had to write that down to 4 significant figures. You had to somehow just show that value was valid to 4 significant figures. What would you do? Your first answer, Angel is wrong. But let's try it anyway. Exactly, I told you it was wrong. And it was. Here's what she wanted to do. And Angel, I have not had a person say this correctly ever, so you're with everybody else. She said to do this, I believe. What's wrong with that?
Change the value.
Changes the value. Write it in scientific notation. All right, hey, tomorrow, and I'll throw out an announcement on Canvas, bring your goggles and wear shoes. I'll let you figure out the implications of that. Bring your goggles, wear shoes. Is this 9th period?
Yes.
Oh my gosh. You do the same. You do the same.
I'm trying to go to Mr. Borzak's and tell him thanks, but he's just not been there.
I know that. He's in process of trying to live.
Before school, 3 a.m. tomorrow.
What?
I'm challenging him to a breaststroke. 3 a.m. tomorrow.
Me?
No, him.
Oh, I have no idea what you're talking about.
Now that I have the thing done, how do you want me to print it out? 'Cause
How do you want to print it out?
I can print out like, you know.
Oh, where do you want to? Okay, I see.
I mean, like I can print it out here and.
Why don't you just want to send it to me?
Sure.
And then I can
All right.
do.
I'll share it on.
Yes, or whatever.
Right.
Is that going to work? What
Yeah.
did you do it on?
I did it on Friday.
Oh, you did?
Yeah.
Because I don't like that. I don't like that. But anyway,
Well,
just because I usually am a little bit more particular about how things show up. But that's fine. Here, yeah.